All right, Lab 6, Saturation and Atmosphere Stability, questions 18 through 25. This is part 2, and this is going to be the lab for the next week set. So I'm going to start with question 18. And we're talking about the mountain example. And as a reminder, our dry adiabatic lapse rate is 10 degrees Celsius every 1 kilometer. And the wet adiabatic lapse rate, which was in the reading part of question 18. So we read the paragraph, and it gives us this fact in our paragraph set. I'm going to fly back to the picture now. Gives us 5 degrees Celsius every 1 kilometer. There's also the understood dew point lapse rate, and that is 2 degrees Celsius every 1 kilometer. Now there's an interesting factor that comes up in the reading, and that is the fact that when the dew point temperature is met, the dew point temperature becomes the temperature of the cloud. So if the lifting condensation level is met at 20 degrees Celsius, both the cloud temperature is 20 degrees C, so that's standard temp, and the dew point temperature would also be 20 degrees C. So if I go up another 1,000 meters and my wet adiabatic rate is 5, if I've met my dew point, it stays 5. So that means that the next 1,000 meters up from my lifting condensation level would be 15 degrees C, and that's my standard temperature, and my dew point temperature is also 15 degrees C. I'm going to see how that works because I'm going to work with you through the mountain equation. All right, so I'm at sea level, and I'm at 25 degrees C for my temperature, and my dew point temperature at sea level is 13 degrees C. I'm going to shove my air mouse up over the mountain range. So I have topographic lifting for my cloud. And so 5 meters up is halfway. Halfway of 10 is 5. So I'm subtracting 5 here. And that is going to give me 20 degrees. In this case, I'm dew point and I'm going up, and it's 2 degrees every 1,000 meters, and therefore I'm subtracting half of it, and that's 1, and this is going to give me 12 degrees C. I'm going to work my way up. I'm now going the other half, so that gives me 15, and this one is 11. This one here, going up by another 5, gives me 10, and this one here is 10. So right here is my lifting condensation level. This is my LCL. LCL. This is the start of the cloud. Now that I've done this, I've met dew point, so my dew point temperature is going to stay the same. I'm also going to flip to my wet adiabatic lapse rate of 5 degrees C every 1K. And so this is halfway, which means I'm going to go down by 2.5, and that's going to give me 7.5. This is going to also be 7.5. This is going up another one, and so this is 5, and this is 5. So now that I've gotten to the top of my mountain and I'm about ready to go up and over, I'm going to descend. And when I begin that descent, I'm going to start to warm up. I'm going to return to my rates that are no longer wet. So I'm going to return my dry adiabatic rate. It also means that my dew point is no longer met, so it is going to begin to heat up. And so in this first step, where I'm going from 2,500 meters to 2,000 meters, I'm going to increase my temperature by 5 degrees. And so this one is going to go to 10 degrees C. So I'm going to add 5. My dew point is going up a half a step from its understood 2 degrees every 1 kilometer. And so I'm going from 5 to 6 degrees C. I'm adding 1. Now for the next step, I'm actually going to go the full 1 kilometer or 1,000 meter step, and so I'm going to warm up by the full descent. And so in this case, I'm warming up by 10, and that gives me 20 degrees C. And this one, I'm going to warm up by the 2 steps, and that's going to give me 8 degrees C. Finally, I'm going back down the extra 1,000 meters, and so I'm going for a full step again. And so I'm going to warm up by the full 10 degrees on my dry rate, giving me 30 degrees C. And on this side, I'm warming up by the full, and therefore I'm warming up by 2, and that gives me 10 degrees C. Now there's some understandings that we need to observe, and that is my starting rate over here was 25 degrees C on this side of the mountain, and that my dew point was 13 degrees C. So this side, it was cooler and wetter, where this side, it is warmer and drier. 30 degrees C by 10 degrees C. So there's some understandings, and this is your standard rain shadow. This is what occurs over the Rocky Mountains, that occurs and creates that wet coast on the west coast, then flows up over the mountain ranges and creates that dry Mojave Desert on the backside, the leeward side. And this is actually a depiction of true climatic events. All right, so for the rest of the questions of 19 through 21, they're based on the mountain example. And so you're just answering things like at what height was the lifting condensation level, and what is occurring, why is it warmer on one side of the mountain over the other. So you're explaining what happened. And as you move on, it then brings you into the paragraphs about atmospheric stability. And this is where we combine the environmental lapse rate, the ELR, with the adiabatic concepts that we've been talking about. And it starts you out by having you work on the table, which is on page 60. And this is going back to that image that we were drawing, where I had you graphing the lines and setting up that setup. And so they have you working on the table, and they give you a starting temperature of 31 degrees Celsius and your dew point of 23. And remember, when you meet your dew point, that is the temperature. And so I'm going to work my way up with you till we hit the lifting condensation level. So I'm going up a half a kilometer, and so I'm going to go down by 5 instead of 10, because I'm not going the full step, and that gives me 26. And then for the next one, 21. Where over at the dew point, I'm starting at 23, and so I'm going down one step, 1 degree, 22, 21, making my lifting condensation level occur right at 1 kilometer. Which means for the next set, I move to the wet rate. And they told us in the first set of the question, in question 23, they give us the wet adiabatic lapse rate of 5 degrees every 1K. And so on this set, I'm going to go between these two at 2.5. And so in this case, same step, because now the dew point has been met, and I get 18.5 and 18.5. I'm going to continue that all the way up till I meet my number set in the height based on my parcels. So work your way through. When you get done, you're going to have tables that consist of the environmental lapse rate, the ELR, the adiabatic lapse rate, both the dry and the wet, and your dew point temperature lapse rate. And so you're going to have these 3 sets of data. And then they're going to ask you to graph them. And if we turn our page, you can see your graph set, and they want you to depict in the cloud cover what's happening. What you want to remember that if you cross the environmental lapse rate line where it is warmer then stability in the atmosphere has occurred. So the atmosphere has become stable, and the cloud actually stops growing in that region. And so if we're looking at the example here, we can see that our environmental lapse rate temperature right along here, it stays colder here, adiabatic, and then all of a sudden we cross back and we cross back over. And so we can see that we start out unstable, then stable, then unstable again. And so we have dry rate, wet rate, no cloud, cloud again. And so we can observe that change based on the standard rate of our environment. So you're doing something similar where you're going to graph up your parcel set here, and then you're going to draw out what's occurring with the cloud in the image to the side, moving from your dry rate to your wet rate at the lifting condensation level, which on our graphing we found occurs at 1 kilometer. This is the lifting condensation level. So we know there is a cloud bottom at 1K. So right here at 1K, I'm going to see you make a little fluffy cloud bottom. Then you're going to show me whether it continues or ends. And that's all part of question 24. And then in question 25, you're going to give me what type of cloud this is and sort of what's occurring. And as a hint, it mentions, would you forecast thunderstorms during these conditions? Remember that your thunderstorm cloud, thunderstorm symbol, your thunderstorm cloud is a vertical cumulus nimbus cloud. If you do not see a vertical cumulus nimbus cloud, then the answer would be no. If you do, then the answer would be yes. So keep in mind the type of cloud cover you see determines what you're going to predict. To help you predict these conditions, you can use the table in your book. In the back of your book is this fabulous table that shows you all of the weather conditions. So that is your walkthrough for part 2. Take your time, maybe pull out your notes from the work in class, and remember to ask questions.